physics, and philosophy. Everything we know about our universe hinges on mechanism, process, and causality. We strive to understand the reasons.
Ghosts and shadows are two of the eeriest things we encounter on Earth. But when it comes to the cosmos, they're even more mysterious. They tell us secrets about our universe, reveal things our ordinary eyes can't see, and challenge everything we think we know about the world. In this video, we will uncover the science behind cosmic ghosts and shadows, the mysteries of their formation, and what their existence means for the future of mankind.
Sense of appreciation, just knowing the conditions on planet Earth can even support life at all, when we see the hellish conditions elsewhere in the solar system.
Before the 1970s, scientists believed that the universe, or most of it, was composed of the physical elements we could see with the eyes or through telescopes. They believed elements like stars, gas, and dust accounted for the mass of the universe, and that brighter entities contained more mass from these elements. They also thought that galaxies were just stars orbiting around a center, kept in place by the gravitational pull of the physical matter.
Stars near the center of a galaxy would be orbiting very rapidly, and stars at the outside would be going very slowly.
American astronomer Vera Rubin and her colleague, Kent Ford, started studying the rotation curves of spiral galaxies. They were measuring the speed with which each star orbited the center. According to Newton's laws of motion, gravity is expected to act on the object moving around the center. Hence, they expected the objects closer to the center to move faster than objects far away from it.
President Bill Clinton presented Rubin with the National Medal of Science in 1993.
It's the same concept as planets rotating around the sun, where farther planets like Neptune would move slower than Earth and Earth slower than Mercury, which is the closest to the sun. But something shocking happened. The scientists were surprised to learn that entities in a galaxy were moving at the same pace irrespective of the distance from the center. This discovery defied the established theory about gravitational force. After repeating their experiment on other galaxies, they discovered the same thing, which led to a groundbreaking finding. There's a considerable amount of hidden mass exerting extra gravitational force in the objects. As their experiment revealed, the telescopes have not been picking up the entire mass, but only the visible part, 5 to 10 times less than the entire thing. The rest were ghosts that couldn't be seen, and they were referred to as dark matter. But their finding wasn't new. It echoed an earlier theory from the 1930s by Swiss astronomer Fritz Zwicky. Zwicky was studying clustered galaxies and noted that they were moving too fast to be held together. He posited that an unseen mass was holding them together, and was the one who coined the term Dunkle Materie, German for dark matter. His findings were largely ignored. Scientists believed he missed out on some of the visible matter or made a mistake while calculating the speed. However, Rubin confirmed his position by measuring single galaxies. These findings provided the bedrock for concepts like cosmic ghosts and shadows, materials that we cannot see but are in existence. The concept of ghosts has always been fascinating, largely unbelievable because humans give credence to things they can see physically, touch, and describe. But as unbelievable as it might sound, science may be helping us prove their existence. Ghosts are things whose presence we can feel without seeing them. If you've ever been in a position where you can't shake off the strange feeling of being watched, you may describe the experience as encountering a ghost. Even if you've never been in such a situation, we've all seen it in movies and paranormal television shows. Doors and multiple windows suddenly throwing themselves open amidst lightning, and a violent wind blowing curtains and dislodging photo frames from the walls. Even after the protagonist manages to shut the windows and doors for the umpteenth time, they're confronted with eerie movements without seeing the entity responsible. Cosmic ghosts are almost similar. While they operate differently and lack the hunting nature of ghosts in paranormal activities, they exhibit the same properties of being hidden, even though scientists have been able to detect their effects.
Galaxy. This is our sun. And now, new technologies are allowing us to see it.
Think of a world where the sun is no more. You step out during the brightest hours of the day, but you look up and the sun is gone. Even after multiple deep space explorations, scientists can't figure out where the sun is gone. But right here on Earth, we can still feel a faint warmth. That's precisely how a cosmic ghost behaves. They are remnants of previously existing entities. Cosmic ghosts are created from objects that exist in the past, such as dead galaxies, fading quasars, or scattered debris of stars that exploded many years ago.
Across the universe, an endless war rages.
When these objects die, they leave footprints that are not living or active and cannot glow like the active entities in the galaxy. They just orbit the Milky Way, quietly lurking in the shadows. Apart from dark matter, there are other examples of cosmic ghosts, like neutrinos and primordial black holes. More on those later, but first, let's look at other entities that establish the existence of ghosts.
The solar storm carries a 1-2 punch.
Remember how we described cosmic ghosts as a long-gone sun, whose warmth we could still feel? For cosmic shadows, the sun is around and shining. You're standing directly under it, but somehow can't feel the warmth because a hidden object is blocking it. Cosmic shadows are areas where the passage of light or other forms of radiation is blocked or diminished due to the presence of celestial objects. They are regions in space where things we can't see are blocking, absorbing, or bending light from stars and other cosmic sources. However, since there are no walls or sidewalks in space, cosmic shadows are not cast on any surface. The shadow is seen by contrast with the surrounding glow, like a silhouette. Cosmic shadows form because of how light interacts with matter. On Earth, shadows are formed when opaque objects block the path of light and cast a dark image on a nearby surface. In space, surfaces are not easy to come by. Light can travel for billions of years without interruption. So, shadows are formed differently. When a star shines light on a cloud of dust, the dust particles can absorb the light before converting it to heat, or emitting it as a different wavelength. Dust particles can scatter the light and direct it in other directions. They can also reflect or refract the light. However, if the cloud is dense enough such that visible light cannot pass through, it will create a dark patch that can be observed against a brighter background. The more fascinating part is that there are different wavelengths of light, and each one behaves differently. Dust and gas particles will block visible light easily, but not infrared light or radio waves. This is why visible lights will look dark when viewed with a telescope.
Exists in its place at the very least. Because without a substantial source of missing mass, the present-day layout and structure of the universe would simply not be possible.
The most common type of cosmic ghost is dark matter. This is a hypothetical form of matter that is thought to make up a large portion of the universe's mass, but does not interact with light, making it invisible. It can only be detected through its gravitational effects on visible matter. Dark matter constitutes 85% of total mass, with visible mass taking only 5%. We have a whole video where we uncovered the mysteries of dark matter. You can click the link below or check our channel.
Neutrinos form during nuclear fusion reactions inside the core of stars. Hydrogen atoms collide, fuse into helium.
Meanwhile, neutrinos are subatomic particles that interact very weakly with matter, meaning they can pass through the Earth and even the Sun without interacting, making them difficult to detect. They are often referred to as ghosts due to their elusive nature. Proposed in 1930 by Wolfgang Pauli and confirmed experimentally in 1956, neutrinos are tiny and neutral. Trillions of these particles can pass through your body without leaving any trace. Large numbers of neutrinos are produced during nuclear reactions in stars, supernova explosions, and man-made nuclear reactors. In 1987, neutrinos were detected on Earth after escaping from supernova 1987A. They were seen some hours before the visible lights of the explosion reached Earth. This shows the importance of the particles in reporting astrophysical events. Still, they're ghosts that cannot be easily detected, except with the help of large detectors like the Super Kamiokande in Japan.
Like there. A black hole's gravity is so strong that even light can't get out. That's why you'll never see one, but you can detect it from the gamma ray bursts that the hole emits.
Black holes are regions of the universe that have gravity so dense that it does not allow anything to pass through, not even light. Most black holes are formed when massive stars collapse. Primordial black holes are hypothetical black holes that are believed to have formed in the very early universe. They are challenging to detect because they are small and do not emit much radiation. Actual black holes can be traced to visible stellar remnants, but primordial black holes are invisible. To detect them, scientists comb for fingerprints, such as faint radiation, lensing effects, and gravitational waves. In the 1940s, Dutch-American astronomer Bart Bok proposed the idea of Bok globules. These are small, isolated clouds of cold gas and cosmic dust blocking out the light behind them due to their high density. They appear as dark, smudgy patches against their vibrant background, which is a glowing nebula. One of the most iconic cosmic shadows is the Horsehead Nebula, a dark nebula located in the Orion constellation. A dark nebula is a dense interstellar cloud obscuring visible wavelengths of light from objects behind it. This is caused by interstellar dust grains in the coldest regions of molecular clouds. Dark clouds or nebulae are able to block the passage of visible wavelengths of light because they contain extremely tiny dust particles coated with nitrogen and frozen carbon monoxide. They also contain molecular hydrogen, atomic helium, and ammonia, amongst others. The Horsehead Nebula is so named because it resembles the shape of a horse's head, located 1,375 light-years from Earth. This dark nebula is not visible because it emits light, but because it casts a shadow that prevents us from seeing light. It's also not a traditional shadow, but a three-dimensional silhouette cast in space. Another particle that can cast cosmic shadows is cosmic rays. These are charged high-energy particles from outer space that travel across the universe. They originate from supernovae, galactic nuclei, sun, stars, and black holes. While they move fast, they're rendered harmless when they come in contact with the Earth's atmosphere. On meeting the atmosphere, they produce showers of secondary particles that can be detected. This also happens when the sun and moon can block or deflect some of the cosmic rays, creating shadows where the number of cosmic rays is reduced. Light can also create shadows. Cosmic shadows are usually about objects we can't see, but objects in space, like stars, gas clouds, or dust, can cast shadows by blocking light from more distant objects. So, where and what are the possible intersections among the cosmic concepts we've discussed so far? The universe has a unique language, most of which appears as riddles to humankind. Getting to the root of these puzzles would help us understand how the universe works. Three concepts that demonstrate this are Hanny's Vorwerp, gravitational lensing, and neutrino trapping. Not only do they show the interconnected nature of the world, but also a unique aspect of the universe where absence signifies presence.
A glowing green blob of gas is floating in space near a spiral galaxy, IC 2497. The object is so huge.
Hanny's Vorwerp is a cosmic object discovered by a volunteer astronomer through the Galaxy Zoo project. It's a mysterious, bright, and elongated object, possibly a remnant of a star cluster interacting with a larger galaxy. In 2007, the Galaxy Zoo project, an online science project that encourages volunteers to participate in science experiments using data from the Sloan Digital Sky Survey, led to a fascinating discovery. A Dutch schoolteacher named Hanny van Arkel was observing the swirling spiral arms and elliptical bulges of distant galaxies when she noticed something unusual. Hannay saw a bright greenish, amorphous blob below the galaxy IC 2497. Scientists called it Hannay's voorwerp, which is Hannay's object in Dutch. The object was strange because it glowed intensely in visible light, even when there was no active galactic nucleus. The galaxy IC 2497 had no visible black hole at the center. Hence, it was not clear what could be powering up these objects. Astronomers say IC 2497 used to host an extremely bright quasar that emitted intense radiation that blasted into space and illuminated nearby gas clouds. The only problem is, at the time of observing the galaxy, the light was no longer shining. The quasar had faded and produced no lightning it once did. Despite this, the light it used to emit had reached the gas clouds, making it shine bright. Scientists call this phenomena a light echo. It's a delayed reflection from a past event. This discovery shows how cosmic ghosts can linger for a long time. Even though the source is no longer present, the energetic activity remained in place and was discovered, highlighting how the universe stores memories from past events. Gravitational lensing is a phenomenon predicted by Einstein's theory of relativity. It posited that the gravity of massive objects can bend or distort the light from more distant objects, creating a lens effect that can make them appear brighter or larger, or even create multiple images of the same object. Not only can this gravity magnify, stretch, and duplicate the background object, but it can also form arcs, or rings known as Einstein's rings. For astronomers, gravitational lensing is both a blessing and a curse. The former is because it can act as a natural telescope, allowing us to see distant and faint objects. For instance, the Hubble Space Telescope's frontier fields used gravitational lensing from massive galaxy clusters to look further inside the universe. Gravitational lensing becomes a nuisance when it distorts observations. Meanwhile, lensing also helps with mapping invisible mass, especially when it comes to dark matter. Scientists measure how much light is bent and compare it to what is visible to obtain a degree of hidden mass. Unlike Hannay's voorwerp, which echoes the past, gravitational lensing distorts present light, helping us to uncover hidden layers of the cosmos. As for neutrino trapping, it occurs during neutron-star mergers, one of the most violent events in the universe. Neutron stars are the ultra-dense remnants of massive stars that have exploded in supernovae. When two neutron stars spiral into each other, they release titanic energy in the form of gravitational waves, gamma-ray bursts, and a shower of neutrinos that do not interact with anything. However, during a neutron-star merger, the extreme heat and density can trap neutrinos in the hot, dense interface between the merging stars, briefly interacting with the matter and helping to re-establish thermal equilibrium in the rapidly changing environment. These momentary neutrino interactions can influence the creation of heavy elements, like gold and platinum, through a process called R-process nucleosynthesis. In other words, the gold in your wedding ring may exist because neutrinos got trapped in the aftermath of a neutron-star collision. Neutrino trapping can also reveal another kind of shadow by revealing the opacity of space under certain extreme conditions. In essence, the terms cosmic ghosts and cosmic shadows highlight the limitations of our current observational capabilities and the hidden aspects of the universe that scientists are actively trying to understand. They challenge our assumptions that seeing is knowing, that brightness equals importance, and that darkness is empty. In truth, some sections of humanity have always believed that darkness is not necessarily emptiness, even if they're also not sure what lurks in there. However, the two terms we have explored in this video also reveal essential points. For instance, to call something a ghost implies that it was once alive, in a more energetic and visible state. Whether galaxy, quasar, or supernova, they leave behind a detectable signature informing us of their prior existence. Meanwhile, shadows imply objects blocking lights even if they are invisible in this case. They tell us our eyes may not be designed to grasp the entirety of the universe. But who knows? Technology continues to advance, and we may well be able to create glasses or other devices that make it easier to see these objects. At the end of the day, cosmic shadows and ghosts contribute to the narrative that what we can see is only a small fraction of the entire package in our universe. It's not clear yet how these phenomena interact with each other or with other things and how these interactions can affect us. Research is always ongoing, and we can only wait until we have more information. Until then, we can try to piece together what we already know. For more on space science and dark matter, click on the video appearing on the screen. See you there!